How important is clean power? Kevin in Monroe, Louisiana. Kevin writes, clean power for a hi-fi system seems to be what everybody wants, but why? How can you tell or measure noise in your AC, and what type of improvements or change to the sound could one expect in general from adding something like a PS Audio AC regenerator? Are the differences as significant as component upgrades? Good question. It's one we get asked a lot, obviously, because we make a lot of power products, and the ones that are really important in this company are the power regenerators. So here's one. This is a P15, the successor to the P10 power plant, which used to be our biggest, and now we have another one that's called the P20. It's even bigger. And let's start at the very beginning of this thing. How important is clean power? Well, it turns out that just clean power itself isn't all that important. It can be. I mean, you can hear, if you take a standard power conditioner, you pick your poison. You can get power conditioners, cleaners, filters from high-end companies, from Walmart. You can get them just about anywhere. And they run the power through basically a coil wire and a capacitor, depending on, the ones at Walmart aren't coils of wire, and they're just capacitors. But let's say that you picked up a decent power conditioner from a high-end audio company or from a power products company of some kind. And there are a number of them out there. Essentially what you're doing is you're running it through a coil of wire called an inductor, and then you're rolling off the higher frequencies, the noise, cell phones, televisions, radios, interference, whatnot. And you can clearly hear a difference. If you take one of those conditioners and you plug it in and you plug your equipment into it, you'll get a little bit better, little cleaner sound to it. But you'll also lose some of the dynamics and the life of the music. So it's sort of a trade-off. So how does that really affect the sound, and why? Well, there are a number of theories as to why all of that, because at the end of the day, depending on the product, you're taking that power, you're converting it over to DC, you're getting rid of any of that AC off to ground, and what comes out doesn't really have any of that noise. So why are you hearing something different when you put a filter onto the AC? One of the reasons has to do with impedance. When you raise the impedance of a power supply, of a transformer, and this is a fairly easy experiment to make, it will sound different. It will sound, I don't want to say cleaner, but it will remove some of the upper and the lower bits, some of the impact, and the bottom end seem to get weaker, and the top end seems to get cleaner, if you will, by raising the impedance, which sort of makes sense in that you're eliminating some of those higher frequency noises and whatnot that can contaminate the ground. But when we look at an actual signal coming out, we don't see any difference in the signal and the purity itself based on the purity of the power. So in my opinion, after all the years of doing all of this, I think that the cleaning of the power is not all that important, and really what you're hearing is the raising of impedance on the transformer or the line by adding an impedance, which, without getting too involved in it, also affects how all the diode switching that's going on in your power supply is transferring back to another piece of equipment. You're isolating that more with that higher impedance, so that each piece of equipment is affecting less the others that are tied in to your group of connected products. as well the radiated emissions from those diodes. And you can easily see them. I think I've shown you here my little tester where you can hear, you bring it near to a diode bridge, that thing is spewing the switching noise that's coming out of the diodes turning on and turning off. And anyway, so that's sort of a synopsis of putting a ball around that whole sort of idea, just to give you an idea. So I don't think clean power itself is all that important. But here's what is important. And here are the factors that are important. Two things. One, as I mentioned, output impedance. When we raise output impedance, it definitely changes the sound, not always for the better, mostly for the worse. But lowering output impedance makes a tremendous difference. A tremendous difference. That's why bigger transformers for the same amount of current sound better than smaller transformers. It's why regulating the voltage going into your products makes a big difference. When we regulate the voltage, by default, the impedance is dropping rather dramatically. How do we measure impedance? We just simply put a resistor going into a source, we put an opposite signal, and we see how much it changes. Well, if it's regulated and we start drawing current through that, or we put a reverse signal in, either way, if it doesn't move, then its impedance is very low. And the less it moves when we start drawing current, or we put in something to demand current at the same time, if it doesn't move, it means it's regulated and the impedance is low. Second part is the top of the sine wave. Most products take current only at the peak of the sine wave. So only when the sine wave goes all the way up to the top is when it's delivering its current to your product. And if that peak of the sine wave is lopped off, as it often is in people's homes, who we all share the line with, and that's why everything's drawing down at the same time, and so your neighbors are causing your trouble, then you don't get all the voltage you need when you need it to charge your caps, and thus your ripple current is different, thus you don't get the full energy that you need out of the wall. That may or may not make a difference if you have a regulated power supply, but in a power amp, of course, you don't typically have one. So those are the two big factors, and those are the factors that a power plant fixes. We dramatically lower output impedance. We regulate the voltage, and we get rid of the whole problem of flat topping. We replace all that energy, and we do it all because, well, that's inside is a big power amplifier with a lot of energy storage, and it's a device that basically AC to DC back to AC again, but this time it's rather perfect. So that's what's important, not so much the cleanliness of the power, it's the impedance, you want it low, and it's the ability to replace missing energy. You want that to be rather perfect. Now, last question, how do you tell? Well, on our products, if you can see on here, I think you can see, there's a metering system. We give you a full THD analyzer. The THD will tell you, the higher the THD, the more distortion of the sine wave, usually because it's lopped off on the top, as I spoke. So if you have very low distortion, like right here, we've got 0.01% distortion. And coming in, there's close to 3% distortion. That 3%, if you were to look at it on an oscilloscope, which of course we also offer, you can see here, there it is. I don't know how well you can see, but we also give you a full oscilloscope so you can look and see what the power coming in looks like, what the power going out looks like, what the distortion, which you don't want, looks like, and what the regulation looks like. So you've got a complete analyzing program built right into these products, and that is how you tell. And that's a whole nother story in itself. But I hope that answers your question, and I appreciate you asking it. Thanks. Bye-bye.